All right, we're continuing simplifying radicals. We talked about multiplication on Friday. If you remember, our rule was something like if you had square root of 24, you could break it into its factors. The idea being we could break apart, if you have multiplication inside a square root, you can break it apart into multiple square roots if that's convenient, or potentially, so you can go one direction, equality means you can go the other direction. So we have that ability with multiplication. And so we're going to talk about how do you do the same sort of idea when you have division. So at times, for instance, we see the fraction 1 over 49. You see the fraction 1 over 49. It might be helpful that we can use this property similar with fractions, division, and we can break it into two separate square roots to make it something easier that we could take the square root of the numerator and the square root of the denominator. So square root of 25, square over 81, obviously, well, not obviously, maybe. First, you do want to check and see, can you simplify this fraction? So make sure you simplify the fraction first. It'll make your life easier in the end. And then step 2 would be to break the fraction apart. Break the root. Whoops, sorry, break square root apart. So we take square root of 25, square root of 81, and we can take those individually because it couldn't have been simplified on its own. 5 over 9, our final answer. So whereas you might want to break apart a fraction, there's also a case where you might want to instead put that fraction all under one square root. So if we put 72x to the third over 8x into one square root, this gives us a fraction we can simplify, and hopefully in the end what happens is the result is easier, something easier to take the square root of. That's the idea why we break apart square roots, why we kind of put them back together, is to make this something that's easier to simplify. So 72 over 8, both of those are numbers that divide by 8. If you divide 72 by 8, you get 9. Left in the numerator, 8 divided by 8 is 1, so we're not going to place the 1. Well, actually, we'll place the 1 in the denominator. If we look at the x's can cancel, what's our rule for division and canceling x's, canceling like bases, would be we're going to subtract. So x to the third minus 1 would be x to the second. So we're left with the square root of 9x to the second, which is something that's much simpler to take the square root of than our original problem. So 9 is 3 and 3, which we can take the square root of that. We have a pair of x's, we can take the square root of that. And the final solution, the final simplification would be 3x. Take a minute, try this one on your own. The last piece we need to talk about with division is this idea of rationalizing the denominator. If you remember rational numbers, were numbers that can be written as fractions. So one rule in simplifying is that we can't leave irrational numbers in the denominator. So here we have an irrational number left in the denominator. We need to figure out a way to simplify this so there's no longer that irrational in the denominator. Numerator's fine, can't be in the denominator though. So how are we going to get rid of that square root of 5? Well, we're going to do similar to a rule property that I showed you guys on Friday, which was if I multiply a square root by itself, I end up with square root of 5 times square root of 5 just gives me the number itself, gives me 5. So I can simplify square root in that way. The only thing is I have to remember to multiply both the numerator and denominator by that number. The reason being is that's the same, root 5 over root 5 is the same as just multiplying the number by 1. And that doesn't change any of the values, it just kind of manipulates them and makes it an acceptable form. So if we have any square root in a denominator, so if we have a square root in a denominator, so our square root of 7 on the second problem, It's automatically telling us something needs to be done before this is totally simplified. Try the two problems, the one on the previous slide and the one I've left you with here. We'll talk about those on Monday, as well as one other form where rationalizing the denominator is necessary. Have a wonderful weekend. See you on Monday.